for Tuesday, 9/24. We're going to try and finish this lesson. One thing that I just added is this other notation. You can kind of look at this on the Yola site notes and see that as well. We just spent a few minutes writing the directions for solving a system of inequalities, and you can look at that on the Yola site, or just pause this. And now we're actually going to graph some things. I do require you to use a straight edge, and as you go through this, and I will go through this system as we can, I'll use a different color for each line. These are nicely set up so that Y is already alone a little bit. This goes on graph paper. If you want to do the whole thing on graph paper, you might want to do that. If you want to write the inequalities into equations on notebook paper, that's fine too. But sometimes if it's all together, that's a good thing. Or maybe you're just pasting in the graph. So these are nicely laid out for us because they're already Y is alone. So the two inequalities are Y is greater than or equal to 0.5x minus 3. That'll be my green one. And the other one is Y is less than or equal to negative 2x plus 7. So I'm going to do this green one first, and so I'll just rewrite it here. Y is greater than or equal to 0.5x minus 3. Okay, and so what you really do is you get Y alone, but it already is alone. And so do you agree that this is in slope-intercept form? Give me a little head nod for that. Yes, and so the slope is 0.5. I'm going to write it as 1/2. Does that make sense? That's a little easier for me. Is that okay? And the y-intercept is negative 3. And then I'm just going to use those. And I will say this, when I use this at the board, I have to draw these lines. So I put a lot of points on here. But when I was a student and doing it on paper, I don't necessarily do that. So my y-intercept is at negative 3. My slope is 1/2. So I go up 1 to the right 2, 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 up 1 to the right 2. And if I put a bunch of lines on there, it's easier for me to kind of notice. It is a solid line. I usually try to write that in the notes, especially because it's greater than or equal to. And so I'll get my line drawer, and you're going to use your straight edge. Oh man, they're telling me I have a problem here because I didn't put my intercept at negative 3. I put it at negative 2. So I can fix mine, at least up 1 over 2, 1 over 2, 1 over 2, 1 over 2. So my bad. So if you're listening to this recording, I apologize. But that is the way things go sometimes. And so there it is. Now, when I have this graphed on here, I have to figure out where to shade. And so when I figure out where to shade, I want to check a point using usually the original inequality, just to make sure that I go back to that. And it's written right here. Do you know my favorite point to check? 0, 0. Whenever I can, I like to check the point 0, 0. So I'm going to check a point, and I'm going to choose 0, 0. The only time I can't use 0, 0 is if my line had gone through that 0, 0 point. And so I put in 0. Is 0 greater than or equal to 0.5 times 0 minus 3? Is 0 greater than or equal to negative 3? Yes, so that means that I'm going to shade where 0 is going to 0, 0 is going to be shaded. And I will say these kind of graphs make my files really big, so sometimes I have to kind of modify them or take a picture of it and then put the picture on there. But I'll figure that out as time goes on. So that's that first one. The second one is y is less than or equal to negative 2x plus 7. So for this one, what's my slope? Slope is -2. What's my y-intercept? 7. And I'll try to count better this time. I am sorry for that. So 1, 2, 3, 4, 5, 6, 7. There's my intercept, and then I'm going to go down 2 and to the right 1. Down 2, right 1, down 2, right 1, down 2, right 1. And I'm actually going to go up 2 and back 1. That just is the same thing. It's again a solid line. I'll write myself a note for that. Solid line. And so then I'll do my line drawer and say that again. Oh, you're past me? Is that what you're saying? Oh, before 0, 0. When I checked 0, 0 on the green line, the line doesn't go through there. I checked it, it worked. If it's true, then I shade there. If it had not worked, if it had been false, because 0 is greater than -3. So that's true. So I want to be shading past 0, 0. If it was false, I would not want 0, 0 to be shaded. Does that? And let's see what happens on this one. So let me draw that a little better. So there's my second line, and I forgot to put arrows on the other one, but I'll put those on now. So now I've got my line drawn, and again, it didn't go through 0, 0, so I can check that point. And in this one, I'll get 0 is less than or equal to 7. Is 0 less than 7? Yes, so that's true. So that means that I want to shade where 0, 0 is. So 0, 0 is right here. So essentially, I'm shading below that line. And now in class, and if you're looking at the recording, you'll see this as well. But then when I paste it on my Yola site, I can't put it like this because it's too big of a file then. So do you see where the shading of blue and green overlap? Yes? Then that is my answer region. I know, right? Well, it won't be on my Yola site. I'll just say it that way. And look, I love that I can I can just keep doing it, and it just makes that perfect pattern. I know, right? Yeah, I know. It's awesome. Okay, so got it? Yes. Okay. That is true as well. However, sometimes, and that's why I said go always put it in the original, because sometimes people don't use all their rules, and that only works if y is alone and on the left. That only works if y is alone and on the left. Because think about reflecting that, and then you would be -2x plus 7 is greater than y. You know what I mean? So yeah, you are correct in that, but the standard way is just to make sure that we can see what happens. All right, here's our next one. By the way, y is alone, and that is not always going to happen to you, but it is happening here. And what do you notice about the inequalities? Yes, but what do you notice about the inequality signs? Dashed lines. Does everybody agree? Dashed lines? Dashed lines. And that is actually a good thing to notice. So we'll go y is less than 3x minus 8. I'm just going to write the word dashed line because sometimes I forget. And if you forget, don't try to erase. Think about that last one. If the second line had been dashed and we didn't draw dashed, it just gets to be a little bit of a mess. So my y-intercept is at -8. My slope is at 3. So -8 is right there. And then I go 1, 2, 3 up over 1. 1, 2, 3 up over 1. 1, 2, 3 up and over 1. And hopefully, as we're doing this, and I'm going to, try to remember to do the dashed line. And That's going to go kind of like this. Yep. Yes. So like I'll just use my, well, I better not use my arms because people aren't here. So like suppose that one's solid and that one's dashed and the area region is there. So I mean not this problem, but suppose that happens, right? Then that's okay. You just have a dashed border and a solid border. If it's just less than or just greater than, it's dashed. If it's less than or equal to or greater than or equal to, it's solid. Otherwise, I'm not sure what you're asking me. But I want to know. So ask me in a minute, maybe. Okay, so do we have our line there? And so can I check my favorite point? Yes, 0, 0. And is 0 less than -8? No, 0 is not less. 0 is less than -8 is false. So I don't shade where 0, 0 is, right? I shade over here. And again, Grace is kind of, oops, Grace is, it's kind of below, correct? That where it would hit that y-axis as we go. So that kind of works as well. The other equation is y is greater than 3x plus 4. So here, 4 is the y-intercept. 1, 2, 3, 4. Slope is still 3. 1, 2, 3 over 1. 1, 2, 3 over 1. Down 3, back 1. Down 3, back 1. And it's a dashed line again. And I hate to tell you, but at the board, I am so lucky for these because I can change my line from a solid line to a dashed line if I need to. And then we'll check our point 0, 0. Is 0 greater than 4? No, it is not, correct? And so do I shade at 0, 0? No. So I'm going to shade here. Now, the solution is the overlap. So in this case, what's the solution? No solution. No solution. And I don't know the... No, I'm good to go. I said I wanted to do these two problems. Did I not do them? Yeah. Yeah. Now, wait a minute. Shh. Oh, did I say this isn't due till Thursday? Well, you are very lucky. So, what I'd like to do if, let me quit this recording, and you know what? Just a sec.